Hello everyone and welcome to the lesson Kcse 2018 paper 2 question number 20. The question is on loci. Part A of the question: using a ruler and a pair of compasses only, construct a parallelogram ABCD with line AB below as part of it, such that AD is equal to 7 centimeters and angle BAD is equals to 60 degrees. That is the first part. The second part of the question, so given the line is there, the locus of points equidistant from AB and AD. 3. The perpendicular bisector of BC. B part 1, mark the point P that lies on DC and is equidistant from A, AB and AD. B2, measure BP. Then part C of the question, describe the locus that perpendicular bisector of BC represents. And D, calculate the area of trapezium ABCP. So that is the whole question on loci. Let's go to the first part of the question, that is A part 1. And for A part 1, you're supposed to construct a parallelogram ABCD. You're given the line, AB is there as part of it, then AD is equal to 7 centimeters, and then you're given BAD 60 degrees. Now you're required to know at least one important property of a parallelogram. A parallelogram has two pairs of sides that are opposite each other, that are parallel and equal. Two opposite sides of a parallelogram are equal and parallel. So if I can sketch, just to sketch, if I may complete this one, I'll have something like this. I'll have something like this, whereby I'll have C there and I'll have D there. So these are the pairs. This side should be parallel to this side, and also these are the side that is here should be parallel and equal to this side. So two opposite sides should be parallel and equal. So if for example I take the measurement here, AB, it should be the same with DC. Then if this one is 7, this one should be at least 7, this one should be 7 centimeters. It should be 7 centimeters. So what I'll do, I'll just take the length, I'll measure the length of AB, and then this one I'll proceed. So that is just a sketch. Let us go to the actual construction. Go to the actual construction. So we shall begin by constructing the angle BAD, that is a 60. So the angle should be at A. So let me construct an angle of 60 degrees standing at A. So 60 degrees standing at A. So to construct an angle of 60 degrees at A, this is what you're going to do. You're going to stand at A using any convenient radius. Mark an arc there, and then with the same radius, mark another arc there. Then from there you're going to transfer the same without changing the radius. Stand at this arc, and then standing at that arc, without changing anything, you cut that arc. Once you've done that, take a ruler and join point A to the point of intersection of these. So that is how I'm supposed to do it. So join A to the point of intersection of the two arcs using a straight line. So that is what I want to do. So that is how you join it. So once you do that, that angle should be 60 degrees. Now D should be along that line that you've drawn there. So what I'm going to do, I'll take a measurement of 7 because AD should be 7 centimeters. So what I should do is simply stand at A. So standing at A and measuring, this one should be 7 centimeters. So that is 7 centimeters. Mark that. So that is point D. So what I've already marked here, this one should be point D, and that one is 7 centimeters. Now after doing that, the next thing you're supposed to do is to take the same measurement of 7. Remember the other opposite side, this side should also be 7 centimeters. So what you're going to do, you're going to mark an arc here. With the same measurement of 7, mark an arc there, and then that one is representing 7. Then you're going to take this measurement of AB. You're going to take this measurement, so standing at A, take this measurement of line AB. So that is the measurement. This one is 8. It is exactly 8. So that one should be transferred on the other side because the opposite sides of a parallelogram should be equal. So standing at D, cut that arc that you've made there. So cut that arc. So that point of intersection of those two arcs, this is where we shall have C. This is where we shall have point C. So what you're going to do now is to take a ruler and join. Just join this point B. So join point B. B to the point of intersection of those arcs, and then after doing that, we're going also to join the other side, DC, join DC as well. So join DC like that. Now you have the complete parallelogram. It is there, it says complete. This angle was 60 degrees. This angle was 60 degrees. This one we've measured 7 centimeters, and then this one is 8 centimeters, and this one is 8 centimeters. So it is complete. Now the next thing that you're going to do, let's go to the other question. So everything is done in part 1. So let me go to second question. 2. The locus of points equidistant from AB and AD. The locus of points equidistant from AB and AD. So which type of locus is that? Locus of points equidistant from two sides. The two sides are AB and AD. The locus of points equidistant from two sides, two given sides, that is side AB and AD, is the angle bisector between the two sides. So we are going to bisect the angle that is between AB and AD. How do you bisect that? That is what is going to give the locus of those points. So to do that, we shall stand, just take a pair of compass, then at A here. So standing at A, this is how you bisect it. Use any convenient radius. And since there's something here I want to simplify, since I had already made 2 arcs here, I'll find it okay to use these 2 arcs. Now look at these 2 arcs. There's that arc, and there is also this arc. So I'll not make other arcs to avoid confusion. So I'll just use those 2 arcs. So standing there, you mark that arc on that line that you want. That is line AD. And then the other arc should be on line AB. Then after that, you can change the radius. Then what is wrong with this one? So standing here, standing at that arc, just mark a big arc there, and then with the same radius, stand on that arc and cut that arc. So from there, what you're going to do, just take a ruler, taking a ruler, and join. So join. So join using a straight line. That is the point of intersect. That is the locus of points equidistant from AB and AD. Now, after obtaining that locus, we can go to the next question. Let's go to the next question. The perpendicular bisector of BC, that is part 3, perpendicular bisector of BC. This is what you're going to do. Just take a pair of compasses, standing at B. Just take a pair of compass and stand at B. So stand at B. Then open this one more than half of that line BC. Then may mark an arc here using a different color. So mark an arc there, big arc, then another arc below there, the same radius. Then transfer the same without changing the radius, the same measurement without changing the radius. Standing at C, the same radius, that is very important. Cut that arc and then cut the other arc here. So I have to make this one to be long enough. I have to make this one to be long enough. Yes, it is okay. Now that is how we construct perpendicular bisector of BC. Then from there you can take a ruler and join on the perpendicular bisector of BC. So that is the perpendicular bisector of BC. So that is how we construct the perpendicular bisector of BC. And of course, it bisects line BC into 2 parts and also meets that line at 90 degrees. So that one should be 90 degrees. So that is part 2 of the question. Let's go to the other part. The other part is B part 1. Mark the point P that lies on DC and is equidistant from AB and AD. Mark the point P that lies on DC. So that P should lie on DC and should be equidistant from AB and AD. So let's go to the diagram. So P that lies on DC, and it should be equidistant from AB and AD. So if it should be equidistant from AB and AD, then it should lie on that angle bisector that we constructed there, the angle bisector between those two sides, AD and AB. Then if it should lie on DC, then automatically the point should be here. This is where the point should be. The point should be here, and this is point P. So it should lie on DC, you can see on that, and then it should be between AD and AB. So it should lie along that angle bisector that we constructed. So point P should be there. Now after locating that point, there's something else that we need to do here. Let me go to the other one. Measure BP, that is part 2. Measure BP. Measure BP. So I'll use my pair of compasses. My pair of compasses here is calibrated. I was just stand at B, so standing at B, and then I'll just have to extend. I'll just have to extend my pair of compass up to where I have P. So BP, according to what I can see here, it is a 6.5 centimeters. 6.5 centimeters BP. So that is the length of BP, 6.5 centimeters. So therefore BP is 6.5 centimeters. Then the next question from there, the next question is describe the locus that perpendicular bisector of BC represents. Describe the locus that perpendicular bisector of BC represents. So the perpendicular bisector of BC, which type of locus is that? Now that one is the locus of points equidistant from two fixed points. Two fixed points. The fixed points are B and C. That is simply the description of that type of locus. It is the perpendicular bisector of that line BC. To describe that locus, that is simply the locus of points equidistant from two fixed points, and the two fixed points are B and C. So to give that description, we shall just write that description here, that it is the locus, the locus of points equidistant from two given fixed points, that is from B and C. The locus of points equidistant from B and C. Then the other question, which is the last one, that is D. Calculate the area of trapezium ABCP. Calculate the area of trapezium ABCP. So let us go to the diagram. Let's go to the diagram and see ABCP. ABCP. You can see that ABCP. Now that is trapezium. The area of trapezium is given by a half multiplied by the sum of the two parallel sides times the height, and that is the perpendicular height. So that is how we are supposed to work out that. So what we should ask ourselves is whether we have the two parallel sides. The two parallel sides are AB and PC. AB and PC, those are the two parallel sides. Then the perpendicular height. The perpendicular height. That one we have to construct. We'll have to extend this line here. Have to extend this line. Let's extend this line completely like this. in order to get the perpendicular. I don't have the perpendicular distance like that. Can extend the whole line. So the reason why I'm extending this line, because I don't have the perpendicular height of that trapezium. So just say the trapezium is ABCP, and the two parallel sides are there. AB and CP is the parallel sides, but we don't have the perpendicular height. So to get the perpendicular height, we will need to have to drop a perpendicular from this point. So from C, standing at C, so standing here at C, I'll have to, so standing at C, mark any two arcs any two arcs, provided they touch that line, that extended line, like that. Then you take the pair of compasses, and standing at that point, that is the first point where the arc cut that line extended, I mark an arc there, the same radius without changing. This is the point here, and then I cut that arc. Then from there I can take a ruler and join. So from point C, I drop that perpendicular, so that will give the perpendicular height of that trapezium. So the length of the two parallel sides, we need to get these. The length of two parallel sides are AB, which is, that one is 8 centimeters, and then CP. I have to get that length of CP. Passes is very small, so this one is 1. That is exactly 1 centimeter. That one is 1 centimeter. So this is 1 centimeter, and then the perpendicular height. I just use that one. I can use the pair of compasses here. So standing at C and extending this one, so up that point, this one is 6 centimeters. So the perpendicular height, that is the height is CN. Can indicate this one as N. So CN is 6 centimeters. Now having that, we can now get the area of the trapezium. Having the two parallel sides, AB is parallel to CP. Those are the measurements of AB, and then the perpendicular height is 6 centimeters. So let us go and now calculate. Can now calculate that. So the area of the trapezium, area is equals to half times the sum of the two parallel sides times the height, and this one is half. The sum of the two parallel sides, AB, we've got AB is 8, and then CP is 1, then the height is 6. So this one will give half times 9 times 6. Working out this one should give 27 centimeters squared. That is the area of the trapezium, ABCP. And that is simply how you're supposed to solve that question.